I know that this is going to be 7.6, okay, and it's going to be solving logarithmic and exponential equations. Now, you don't have to write this part down, but I just want to tell you, y'all have lived a long time without knowing how to do logarithms, haven't you? Okay? And so I know sometimes you go, well, I'm pretty sure I've learned a lot of math and I hadn't need a logarithm yet, so I probably not gonna need to know these. All right? But let me show you what the logarithms are used for. Let's say that you have $5,000 and you're going to invest it in something that's going to pay 4% interest compounded every month. Okay? How long do I have to keep that $5,000 in that account in order to have $10,000? Okay? Is that a realistic application or problem? Yeah, y'all. Listen, I mean, whatever your $10,000 may be for, it may be for a car, it may be for a small down payment on a house. Okay, it could be a lot of things, but that's very realistic. So, how do you solve for a variable when it's in the exponent? Have you ever learned that? That's exactly right. Y'all, that's how you do it. So how do you solve an exponential? That's what we're going to learn, because that's what this is. You're solving an exponential. You've got an x, or a variable in the exponent. You've got to figure out how to do it. So here's what you do need to write down. How to solve exponential equations and logarithmic equations. Okay? So, first of all, let's talk about an exponential. How do I solve, about the x. How do I solve an exponential? Well, you're going to isolate, what does that mean? Yeah, get it all by itself. Isolate the, now listen, you can't get that exponent by itself, can you? Okay, so we're going to get, it's called the power. It's the base and the exponent. Okay, so you're going to isolate the power, and then you're going to rewrite it as a logarithm. Okay? How do you solve a logarithmic equation? Oh, you're going to isolate the what? The log. Oh, it's a logarithmic equation. So say the word log or ln in it somewhere. Okay? Isolate. Notice it says the log. Does it say the logs? So how many logs? One. Okay? One. So if I have more than one, what am I going to have to do to them? Condense them like we learned yesterday. Very good. So we're going to isolate the log. Then we're going to rewrite that as a what? An exponent, an exponential. I'm just going to say an exponent. Okay? That's the way you do it. That's the way you solve a logarithmic. That's the way you solve an exponential. That's why we have logarithms, in order to solve our exponential equations. All right, so let's try the first one. You ready? So here's the first one. It looks like this. 2 times 4 to the x minus 1 equals 23. All right. So I would say the very first thing you need to ask yourself is this an exponential or is it a logarithmic? Very good. So, y'all, that's not going to be hard to decide, right? If it says the word log or ln in it, it's logarithmic. It's not going to sneak up on you or anything, okay? So here's what I'm going to do. When I first start out working these problems, I'm going to box in or highlight or something that that power, that's what I'm trying to get by itself. If this said 2a minus 1 equals 23, and you were trying to solve for A, what would you do? Yeah, well, how would you solve for it? Yeah. Okay, so we're going to do the same thing. We're going to add 1. See, these are skills that you already know, all right? So now it's going to be 2 times 4 to the x is equal to what? 24, okay? Now, here it is right here, guys, all right? Divide by 2, Spencer says. So now 4 to the x is equal to 12. All right, everybody okay so far? Did we get the power by itself? Yeah, power's all by itself. So now what are we supposed to do with it? Write it as a log. Oh, okay. So it's log base what? 4 of 12, very good, is equal to x. Log base of the answer is equal to the exponent. All right? Now, yesterday we learned how to do this in our calculators, right? We learned how to go change a base formula. How would I do that? 12 over log 4. Log 12 over log 4. And then we're going to find that, and we're going to write the answer down. We're going to round it off to 3 decimal places. Now, I want you to make sure everybody's got a calculator, because I'm going to show you a secret. I didn't show you this yesterday. All right? So make sure you got your calculator out. Change your base formula? You can, unless you want to listen up to what I got to tell you. Take your little calculator and everybody do this. Go math, alpha, math. Oh, that's a pretty handy little thing, isn't it? Math, alpha, math. All right. Pop that little 4 in there, pop that little 12 in there, and tell me what you get. Round it to 3 decimal places.
1.792.
All right. Don't be late to class, because if you get stuck with calculator, 2742, it don't work. It won't do that. And I can't, the little connection slot, somebody messed it up, stuck a pencil in it or something, and messed it up, so it won't let me download that. There are lots of different ways. There are a lot of different ways that you can get to that change of base formula. Okay, I think that's the easiest way, but there are other ways to get to it. Okay? All right, now, let me show you how to check it. Okay, I'm going to show you how to check it. So everybody take your calculator that you just worked that problem on and go 2 times 4 raised to the, now, yeah, you can pull the answer back down or you can arrow back up to it and highlight it and then press enter and it will pull it back down to there. Okay? And then minus 1 equals, and you should get 23. Did you plug in 1.792? Okay, well you rounded off. If you go back, this is what you went up and brought it back down? Oh, okay.
It rounds, but for some reason answer keeps the whole data file
Oh, okay, rather than highlighting it? All right.
Highlighting just takes
what's on there.
Takes the entire number
and puts it in there. Oh, you use the answer too? Okay. I guess it just depends on... Okay. So anyway, it's close, right? So evidently your calculator's rounding. All right, so here's yours. Are you ready? Here we go. 4 times e to the negative 0.3x, oh, minus 7 equals 13. We're going to like this.
We are learning.
We are learning. This is my last show, y'all. Enjoy it. Oh, I'm so excited. This is my last show.
Until next year.
So,
Okay.
I may not even be...
Castle, the last episode was last night, and and my grandmother loves that show. I walked in, she was crying.
Yeah, because they canceled it. They also canceled Once Upon a Time. That was really too.
They canceled it?
The Family and something else.
I'm really hoping they did not cancel Why I Love. Because if Garrett on the stretch.
Once upon a time was going to go on.
And you can't include.
That's like everything's great. Yeah,
Ooh.
for real. We've been saying this for any.
Okay, let's go. Y'all got this problem worked? Y'all are watching TV. Come on. You bunch of TV-aholics. Oilers.
Oilers number one. Where the Houston?
Yeah. Yeah. You are. That's what I felt like I just said. Yeah.
It's like completely different now.
Hey.
Like different owners. What?
I forgot we're recording.
The Houston.
They're like, I'm so glad I'm not in that woman's class. All right. So tell me what y'all did first.
We boxed it.
And then we shipped it. And then you box it. And then you ship it. Have y'all ever seen that? Oh my gosh. Mrs. Doubtfire? Please. What is wrong with y'all?
I've never seen Mrs. Doubtfire. Me either. I never did.
Okay, now what do I do? Now what do I do? Oh, now I'm going to rewrite it. So what do I say? Perfect. Of what? Thank you. Equals. Awesome. All right. So let's talk about this for a second. So now what am I going to do? Because I need to solve for x.
You're going to divide by -0.3?
Okay, so let me tell you this. You need to practice on this problem because I'm going to tell you, if you got negative like 15 or 16 point something, you're wrong. Okay? It's not right. You don't know what you're doing.
I didn't get that part, though.
Oh, I can't imagine why. That's exactly right. So here's the deal. Guys, you're not taking, this is what happened. Some of the kids were going ln 5 divided by -0.3. That's not what you're doing. You're going ln of 5, and then you're dividing that answer by -0.3. You have to shut those parentheses right there. If you don't shut it, it's going to take the ln of 5 divided by -0.3, and that's not what you want it to take the ln of. Okay? So you should get -5 point what?
365.
Perfect. Look. See, whoever's listening, they are paying attention. All right. So, everybody okay? All right, now let's do a logarithmic equation. All right, so we're going to go log of 8x plus log of x minus 20 equals 3. Okay, so what should we do first? Yeah, you can only have one log, guys, okay? So you've got to put these together. When they add, what are you supposed to do? Multiply. That's what we learned yesterday, all right? So it's going to be log of 8x, open parentheses, x minus 20 equals 3. All right, everybody okay so far? Now, do I have the log by itself? Yeah, because this is all what you're taking the log of, so I can't really do anything with it. All right? So now it's all by itself. So now what am I going to do? We're going to write it as an exponent. What's my base? 10. What's my exponent? Not me. Is equal to, what's my answer? Very good. And yes, Luke, you could have gone ahead and multiplied that if you had wanted to. Okay? So, now let's do this. What's 10 to the third?
1,000.
All right. Let's distribute this 8x and tell me what you get.
8x squared minus 168.
Perfect. Uh-oh. What kind of equation is this?
Quadratic.
How do you solve a quadratic?
Yeah,
Well, first you have to do what to it? Yeah, you got to set it equal to 0, guys. All right? So 0 is equal to 8x squared minus 160 minus 1,000. Now, what might we do to make our lives a little nicer?
Divided by 8.
Yeah, people, divide that thing by 8, all right? So, 0 divided by 8 is still 0. X squared minus, what? How many x's? 20x. Minus, what's 1,000 divided by 8? 125. Now we're going to factor this thing, okay? X and x. What's the minus sign at the end mean? Different signs, plus and minus. That means, what am I doing with the factors of 125? What are you doing? You're subtracting them, people. This sign right here is the cheater sign. He tells you what you're doing. So I'm looking for the factors of 125 that subtract to be 20. People, if you don't know what they are, you take your little calculator, and then you go 125 divided by, what do you want to try first? 5? Oh, look at there. How hard was that? What's the difference between 25 and 5? 20, right? So there it is. That's the answer. It might be more difficult for some of y'all, okay? All right. So I want a negative 20, so who goes by the minus sign?
25.
Perfect. And the 5 goes here. So what is this answer? Negative 5. What is this answer? 25. Okay. Now, everybody got your calculators handy? We're going to check them. Okay? All right. Get your handy-dandy calculator. Punch this in your calculator. I'm plugging the negative 5 in. Log 8 times negative 5. Close the parentheses. Plus log negative 5 minus 20. Close the parentheses. Press enter and see if we get 3. Okay, so let me tell you why it does that. All right? If you plug a negative 5 in right here, 8 times negative 5 is negative 40, right? Tell me what power you can raise 10 to get a negative 40. See, you can't have a negative base. We talked about that, right? And so if it's only a positive base, can you ever get a negative number right here? So this guy right here is extraneous. All right? If you plug the 25 in, he would check. You can check him. Log 8 times 25, close those parentheses, plus log of 25 minus 20, close the parentheses, and it'll tell you it's 3. So my solution is 25. All right, anybody got a question? Everybody okay? All right, let's try another one.
What's the question?
Yeah, and that what we did yesterday and the other day. All right, here's your next problem.
Do we need the cheat sheet?
2 log cheat sheet.
No, we're done with that. I know.
Oh, no, you don't need that. 2 log base 4 of 5x minus 1 plus 5 equals 11. You want me to let y'all do it by yourself? Sure. Okay. Alright, did everybody get to here okay?
Yeah.
Yeah? Alright. Now, once I got it by itself, okay, now I'm going to rewrite it. Now, how do I know that that 5x minus 1 goes with that log? Yeah, it's in parentheses. Okay, they're telling you it all goes together. You can't just pull stuff out of the parentheses. Okay, so now I'm going to write this log as an exponential. What's my base?
4.
What's my exponent?
3.
And what's my answer?
5x minus 7.
Perfect. What is 4 to the third?
64.
Plus 1. So now I got 65 is equal to 5x. Divide by 5, and what is x? 13. And then you can plug it in. Y'all look, it's so easy. You've got that little math alpha math thing right now, okay? So you got 2 times math alpha math. A base of 4. Go up in the other box and say 5 times 13 minus 1. Go outside the box and say plus 5. And when you press enter, you hope it says 11. Does it? Yep. Math alpha math. Alright, everybody okay? We punched in this side right here. 2 times math alpha math. Log base 4. 5 times 13 minus 1. Go outside the box and say plus 5. It's just a solution set. So proper notation says we do, but I'm not counting it wrong if you don't. Okay? Alright. So let's do another one. Let's do this one. Log base 5 of 4x minus 7 is equal to log base 5 of x plus 5. Alright, everybody okay? Tell me, what do you want to do?
Get it all on one side.
Get it all on one side? Okay. So we're going to put it on the left side. Log base 5 of 4x minus 7 minus log base 5 of x plus 5 is equal to 0, right? Now what do I have to do? Got to condense those. When they subtract, what do we do?
Divide.
Okay. So that's going to give me log base 5 of 4x minus 7 over x plus 5. Very good. Equals 0. Okay, now what do I have to do? Yeah, now you got to write it as an exponent. You got the log by itself. You can't really do anything else. So what's my base? What's my exponent?
0.
What's my answer?
4x minus 7 over x plus 5.
What is 5 to the 0?
1.
So I'm going to do this. I'm just going to write it as an exponent. I mean, as an exponent, as a fraction, 1 over 1. And the reason is because I'm just going to work it like a little, what are those things called? Proportion? Right? Cross multiply that thing. Then I'll get 4x minus 7 equals x plus 5. Now what am I going to do with it? Solve for x. I'm going to subtract x from both sides. What's 4x minus x? Okay. Now what am I going to do? Add 7? What's 7 plus 5?
12.
So 3x is 12. What's x got to be? 4. Okay, and then we can check it. But let me show you something. What if we just stopped and thought about this thing? What if I said log base 5 of this is equal to log base 5 of that? What do you know about this and that? If log base 5 of this is equal to log base 5 of that, then this and that have to be equal to each other. So what? You mean I didn't have to do all that stuff? I could have just said, 3x equals 12 and x is 4? Oh, which way? Look, is there anything wrong with this way?
No, we're going to need it.
It's not. There's nothing wrong. Now look, when would you need that way? Yeah, okay, y'all, if it's a different base, you would have to graph, well, you could do it algebraically, but probably don't have the skills. But you would have to graph them on the calculator and see where they intersect. Okay? So, might be a challenge to you. Okay, I've had one kid that's taken that challenge. He was in pre-cal, and he went home and worked for hours and did it algebraically. So, it was pretty cool. Brought it back up here and was like, oh my gosh, Miss Davis, I did it. You said we couldn't, so I went home and did it. No, Zach Blanchard. He's the same kid that letter from MIT.
Oh, okay.
The letter that I have over there from MIT. So he went home and did that. Yeah, it was just a challenge to him. So he didn't go to MIT. He's at the Naval Academy. Yeah. Okay, but now, so that's if the bases were not the same. Here's another time, Luke. If this one right here said plus 2, okay, then I'd have to do it this way. You couldn't do it that way because it has a number out here. You see what I'm saying? And then this would be a 2 right here, and you'd end up with 5 squared is equal to this, and you put over 1, cross multiply, and that would be the only way to work it. Okay? Uh-huh. Yeah. Yeah, you're just going to go log base 5 of...
I did that, but they're not coming out with
the 4 didn't?
Yeah, like I plugged in the...
I think you might have plugged it in wrong.
Mine works.
They're like 0.3 off.
Yeah, they're like 0.3 off. Mine, but it's plugged in right with parentheses and everything. And mine is not.
Here's the new one.
Yeah, that's the exact same thing I have. Are they the same numbers? Mine came out right. Yeah, mine came out right. Mine came out right. Let me reset my calculator.
Okay. I don't know. It should come out right. I mean, it should just because, I mean, I know it checked. All right. Let's try one last problem. Woo. Yeah, always check your answers, guys. Okay? Always check your answers. Because even if you only have one answer, if that one answer is going to create a negative up here, he's extraneous because you can't work it. Okay? That would be there was no solution. Okay? Now look, my pre-cal kids just did a problem like that. They're working on the same stuff that we're doing, except theirs is a little more in-depth than ours. But they worked a problem. 4 was the answer, but when you plugged it back in, it wouldn't check because it created a negative. All right? And so the answer ended up being the null set. So then, when I graded their papers, if they got the null set, I went back to look and see if it said x is equal to 4. If it did, one of the kids got null set, but he got x is equal to 5. Was his correct? It was wrong. I didn't get. He's like, I got null set. She got null set. I missed it. She didn't. And I'm like, yours is not null set. Yours is wrong. You know, that's not an extraneous solution. 5's not extraneous. 5 is incorrect. Okay? 4 is extraneous. So you can't just, you know, do that kind of stuff. I want you to be careful with that. All right. So let's try one real life problem, and then I'll let you get started on your work. Okay? No, you can't like accidentally get it right. Okay. So here is our problem we're going to work with. The reading problems are going to get it. Okay, so we're going to be studying stars today, people. Going to call us an astronomer.
You know it.
All right. So here it is. The apparent magnitude of a star is a measure of the brightness of the star as it appears to observers on the earth. So the apparent magnitude is how bright the star appears to us. Okay? The apparent magnitude, M, of the dimmest star that can be seen with a telescope is given by this function. M is equal to 5 log D, 1 over 2. plus 2. Where D is the diameter in millimeters of the telescope's objective lens. If a telescope can reveal stars with a magnitude of 12, what's the size of its objective lens? So what am I going to do, guys? Plug in 12 for M. Now what am I going to do?
Can you interchange B and X?
Subtract 2 from both sides.
Yeah, just subtract 2 from both sides. What's 12 minus 2?
10.
So 10 equals 5 log D. Y'all, this is a logarithmic equation. Get the log by itself and rewrite it. That's all we're doing. What am I going to do now?
Divide by 5. How do we know if it's not an exponent?
You know what? You could write it as an exponent, but it makes your problem more difficult. Okay? I'm going to show you another one over here. Look at this problem that we did right here. Some of the kids got it right here, and then they pulled that 2 up there and made it an exponent. Well, then you made a quadratic is what you made, right? This becomes 25x squared minus 10x plus 1. Then you're going to have to solve the quadratic. You're going to get 2 answers. I'm guessing one of them is extraneous, okay, because we only got one solution. Okay, so it's not that you can't do that. It's just that if I can get rid of it the other way, it's going to be a whole lot easier on me. All right, so yeah, I would try to divide it out first. Okay, it's just going to be easier. So this divides out, and I get 2 is equal to log D. Now we're going to write it as an exponent. What's my base?
10.
What's my exponent?
2.
What's my answer?
D.
What's 10 squared?
10.
So the diameter of the objective lens, oh sorry, got too many zeros here, got carried away. Of the objective lens of the telescope is 100 millimeters. Okay? That's not bad, is it?
No.
All right. So we're finished. So I'm going to give you a worksheet